Hello and welcome to the presentation about Wangel's A-Level Physics. My name is Miss Fellows Freeman. I'm the Head of Science at Wangel's. And in this presentation, I'm just going to be running you through the structure of the A-Level Physics course. And hopefully that will answer any questions you have. If you do have any further questions or you want more information, feel free to drop us an email at fizz@wangels.wokingham.sch.uk, or you can find us on Twitter at WangelsScience. So A-Level Physics is a fully examined A-Level, so we do have some grade requirements, and we have those in order to support students so that the students taking the course can fully access the whole course and are in the best position to succeed. So our grade requirements are either a grade 6 in physics GCSE or a 6-6 in combined science. We genuinely have no preference for either separate science or combined science, as long as you are succeeding well enough in those exams. All of our evidence shows that you should be able to access the course and continue to do well at A-level. We also want a grade 6 in maths GCSE. The A-level physics course is extremely maths reliant. You don't need the A-level maths to do physics. The maths you're expected to do would be GCSE maths, but it is higher level GCSE maths, and there is an expectation that you are fluent in rearranging equations and using maths terminology. So there is a really, really large maths component. We very, very strongly recommend that A-level physics students also take A-level maths. We have had a few that haven't. They have always struggled. We have a student at the moment who's taking the offer that Wangels does of core maths, and that is helping. So if genuinely A-level maths isn't an option, we really, really would recommend that you look at core maths. The exam board don't say you have to do A-level maths with A-level physics, but it is very, very difficult to succeed at A-level physics if you struggle with the fluency of maths. And if you're not doing maths on a regular basis, you very quickly lose that fluency, just like you lose a fluency of a language. So A-level physics exists as part of the Wangel Science Department. So we've got 3 physics teaching labs. We also have a science sixth form theory teaching room where we occasionally can do physics practicals because they don't involve water or chemicals. We've got 3 experienced physics teachers and 3 science technicians who have been here for years and are very used to preparing A-level practicals to help us and develop our learning. So as part of your physics course, you will develop really specific physics skills. You will learn about constructing circuits. You will learn about measuring accurately measuring acceleration. You will learn about measuring gravity and different ways to measure gravity. But those things won't necessarily take you forward unless you carry on studying physics. But what you will also get is a huge range of analytical skills. There'll be a lot of math skills. You'll be working with equations. You'll be estimating values, using trigonometry. You'll spend a lot of time with graphs, handling data, looking at errors, and you will develop those wider skills. Attention to detail is going to be a big aspect of that course. You'll need to be looking at solving problems. You will need to be organised. The physics A-level course doesn't involve making, hundreds and thousands of pages of notes necessarily, but you will need to be organised. You will need to make sure that you are practicing those techniques all of the time and that you know what topics it is you need to work on, that you need to develop, which topics are you strong on. And that requires a certain amount of organisation and a different type of organisation from GCSE. It's about taking responsibility for your learning, and it's something that we see through the course as we take them through those 2 years, where by the end of that 2-year course we hope to send you out in the world not needing us and being able to go and learn and be able to be independent learners. So, as part of the course, we have to do 12 required practicals, a little bit like you do at GCSE. They're split across 2 years, but we try and put in as much practical as we can because that really, really helps develop your knowledge. A lot of the time in physics, we're talking about complex ideas where you can't see something, we're building a model to help explain it. Electricity is a classic example. So doing practical work really, really helps do that and develop your understanding as well as help identify any misconceptions you might have. Okay, so in the first year, you come in bright-eyed and bushy-tailed to learn some physics. And we start with a new topic. Most of the content of A-level physics continues with ideas you've begun to study at GCSE. But we start with a brand new topic. You kind of have touched on it a little bit at GCSE because we've looked at the atom, but we start looking at particle physics. We start with matter, we start looking at what's inside a proton, what's inside a neutron, we start looking at quarks and leptons and quantum phenomena. So that's a really engaging topic that we start with. We also start with electricity, and we start with electricity because students tend to find it challenging. So that gives us the whole year to keep coming back to those ideas and work on them. But largely, the content in year one is split into kind of 3 topics: the particle physics and waves, then a lot of mechanics, which has got a fair amount of overlap with math, and then the electricity. And there are practicals, the required practicals and other practicals that go with all of those topics. Like the other sciences, we do have an option where after the first year you can take the AS exam. We do have students who choose to do that if they're taking 4 courses in year 12, and they would choose to drop one and carry 3 on to year 13. So if you were to do that, your AS exam would be 2 exams, both covering the whole content you've done so far, and it would be a mixture of questions, including multiple choice questions. A-level physics involves multiple choice. It's usually something that students at GCSE think that is amazing, it's got multiple choice, and as soon as they start seeing the A-level multiple choice, they realise that it is not necessarily amazing. They're quite difficult multiple choice questions, but a good section of your exam in A-level will have a multiple choice component. The vast majority of students, in fact all of the students we have this year, carry on to the second year in physics, where we carry on working on ideas that were originally mentioned at GCSE. We look at gases, we look at gravitational and electric fields, we look at radioactivity, and then towards the end of the year, there's an option unit. So as a group, we decide if we're going to study engineering, electronics, medical physics, turning points, or astrophysics. In the last few years, engineering and astrophysics have been the most popular, with turning points kind of coming up in the rear. We haven't done electronics or medical physics in the time that I've been here, but there is no reason why we couldn't if we had students who wanted to develop those ideas. If we were in a situation when we had 2 classes, we could do 2 options, but in the last few years we've had 1 class and we've chosen an option as a class. When you're doing that A-level assessment, there will be 3 exams. The first one is basically the first year with 1 topic from the second year, periodic motion. Paper 2 is the second year, and those questions they contain multiple choice, but other than that, they're kind of similar to your GCSE. They've got a mixture of short and long answer questions like you've seen in GCSE papers, plus the multiple choice content. Paper 3 is quite different. The first half of paper 3 is questions about practical skills and data analysis. So it might be about the practicals you've completed in the 2 years. It might be a completely new practical that you have to analyse from scratch. And then the second half of paper 3 is your option. So that is where you choose. You don't have all of the options in the exam. You have to tell them beforehand. And you get your paper for astrophysics or engineering, and you answer questions similar to paper 1 and paper 2 on your option topic. So once you have done all that work and you've worked very hard and you've got your physics A-level, there's a huge range of things that you can do. We often have quite a lot of students who go on to engineering, and engineering is a career that is very good at having pathways in at all sorts of stages. So you can go and have a pathway into professional engineering at post 18 and go and do work-based training and do vocational qualifications in engineering. You can go and do an apprenticeship in engineering. You can go and do an apprenticeship building software. Quite a lot of our students do computer science and physics, so that's kind of a natural progression. Or you can continue studying the subject academically, either physics or engineering. You can go on and study at university, or you can use your physics A-level to really support another subject that you're passionate about studying. Applied science, biology, chemistry, engineering, electronics, computing, all sorts of other subjects. Your physics A-level is really going to support. Whilst you're doing it, we will continue to have the online resources you have access to. You will carry on having Caboodle, which includes digital versions of our textbooks, and that is on there now. So if you're a Wayndell student and you have Caboodle, you can go on there now and look at the A-level textbooks and have a nose around. Focus e-learning has also got an A-level component where you can see the A-level practicals. Again, that is on there now. If you're a Wayndell student, you can log on to Focus e-learning and you can have a little look at the A-level practicals. And we also use Isaac Physics, which is an online platform, and it's developed by the University of Cambridge, and it is really in support of problem solving. At GCSE, if we've used Isaac Physics, it's been quite a lot of just calculation questions. Maybe bring in a little bit of problem solving. At A-level, it really is looking at the problem solving. And Isaac Physics actually goes on to first year, second year university level. So that really allows you to access those problems that are going to really help you in terms of getting into universities, thinking about next steps, and looking at what that challenge is going to be in the future. Well, I hope that presentation helped you and helped you to understand a little bit about what A-level physics is like here at Wayndell. If you do have any questions, as I said at the beginning, feel free to drop us an email on fizz@wayndells.wokingham.sch.uk, or you can find us on Twitter at Wayndell Science.